we're looking for the center of our data, and we have this example where we ask people how much they spent on food for 2 weeks. And here are their answers: 250, 320, 400, 200, 210, 400, 1500, 410, and 240. So we might be tempted to just average them and say, okay, the average amount that people spent on food was such and such. We want to see if that's actually a good measure of the center. Does that tell us about how much the average person spent on food? So what we're going to do is we're going to find our 5-number summary. We're going to do that in a calculator this time. So we're going to bring our calculator up, and I have it right here. So I'm going to remind you how to get there. So you push Stat, and then you push Enter on Edit, and it's going to get you to your list. Go ahead and type all of those numbers into your list. Then push Stat, and we're going to calculate our one variable statistics. Our list is list 1. We don't have a frequency list, and we push calculate. Now this is our one variable statistics. Remember, it tells us everything we need to know. If you look at your notes, we have a chart of what each of these things means. So this is the mean right here, $436.67. So we could actually say the average person spends $436.67. At least that's what we would have said before, right? And let's figure out if that's actually true. So we're going to figure out, this is the mean. Here's our standard deviation. We're going to be using our population standard deviation, so that's 384. Our 5-number summaries down here, we've got minimum, quartile 1, median, quartile 4, and maximum. All right, so let's go back to our problem and see if our mean really tells us the middle of our numbers and about what the average person spends. So it said $436, right? Well, when I look at all of these different numbers, I notice that there's only one person in this entire sample that spent more than $436 on food for 2 weeks. So would it make sense for me to say that the average person in my sample spends $436 on food every 2 weeks? Not really, because the mean is not a good measure of center in this case. So let's see, where is this data? Is it skewed left? Is it skewed right? What's going on with it? So we have our 5-number summary here. I already typed it out there for you in our mean. And so we're going to make a box plot. And when we make our box plot, we notice that all of our data basically, let me pull that down a little, all of our data is over here, and we have this really long tail to the right. So this is skewed right, is what it's called, remember, because our big long tail is to the right. Here's our mean right here. And you notice that over 75% of our data, right, because this is 25% and this is 25%, and this is 25%, and this is 25%. Over 75% of our data is below the mean. So it is not a good measure of center. It does not tell us how much the average person spends on food. So when we have a skewed distribution, we see that this one person who buys lobster and steak, and I don't even know how you would spend $1,500 every 2 weeks. Maybe they have a ginormous family. I don't know. But this person over here is skewing the mean. It's bringing the mean way over by it. And so what happens is it makes the mean a really terrible use of measure of center. It doesn't tell us the average of anything. So for a skewed distribution, the mean is a terrible judge. We're going to use the median instead because it tells us much more. If I said about the average person spends about $320 on food every 2 weeks, that actually makes a lot more sense because 50% of the people I surveyed spend less and 50% of the people I surveyed spend more. So our rule of thumb is when data is skewed, we want to use the median to find the center. And when we're using the median to find the center, we always use the interquartile range to find the spread. So those two always go together. Median and interquartile range always go together. So when it's skewed, again, we're going to use the median to tell us the center and interquartile range to find the spread. Now, when data is symmetric, we can use the mean to find the center and the standard deviation to find the spread. And you might be asking, why don't we just use the median and interquartile range for both? Well, the reality is when we have a really big data set, it's a lot more challenging to find the median than it is to find the mean. The mean is something we find all the time and people constantly report it. So when we're using symmetric data, it's just easier to use the mean and the standard deviation. So I want you to remember that. Skewed data uses the median to find the center of the data, and symmetric distributions uses the mean.